Okay, so welcome everyone. This is your first of the electronics experiments, the basics of electric circuits. So what we need in order to do these experiments is our three main pieces of equipment. We've got our breadboard, which serves as our device on how we build our circuits and how we get the necessary voltage to run our circuits. Okay? The second piece of equipment is our multimeter, which is predominantly used to get accurate measurements of our resistance, but also for this first experiment, you will be using it to measure voltages too. And then the third piece of equipment is the oscilloscope. Now this is the main one we use. It gives us all sorts of measurements. It also gives us visualizations of our inputs and outputs to better understand what we're actually measuring and doing. And then the last bit of equipment you need are the specific components for the experiment. So in this case, we've got different sets of resistors, and then we've also got a variety of wires to build our circuits. Right, so now I'm going to show you how to build our first circuit that we're working with. Okay, so what we need to do to start off with is get the exact resistances of our resistors. Okay, so what we'll do for that is we're going to use our multimeter to determine the resistance. Okay, so the easiest way to do this is actually to take advantage of our circuit board here, and instead of trying to hold the probes directly onto the resistor. Okay, so all you do is pick two spots that aren't contained in the same 6 dots or holes. Okay, and then for our multimeter, we're going to change our setting to our resistance block, which is this bottom left-hand corner framed by the green border. Okay, so you'll see these measurements here, the 200, the 2000, the 20K, and so on. Now that tells you what the maximum value of resistance you can measure for each of those are. So for example, if I put it on the 20K, it means I can measure anything 20 and below. Okay, so for this purpose here, I'm measuring a 1 kilo ohm resistor. So if I put it on the 20, that should be sufficient. Okay, so now in order to get our measurements, we just take our 2 probes from our multimeter and touch one to each side of our resistor. Okay, and now you'll see the measurement shows up on our multimeter screen. And then that tells me that this resistor is 1 kilo ohm. Okay? So we know exactly what that resistor is. And then for the other one we need for this experiment is the 2.2 resistor. Okay? So we take one out from the correct bag and we do the same thing to measure. Just pick 2 random points on your board, making sure the legs aren't connected so as they're not on the same holes, and we do the same procedure. Since this is 2.2, the same setting on our multimeter should be sufficient. You touch one probe to each leg, and then we see for this one it is 2.2 kilo ohms as we had hoped for. Okay. So now we know we've got the 2 correct resistors. What we want to do is now start building our circuit. So you'll see in the template that you'll be provided with before you see these talks is we need to build a voltage divider circuit. Now that's simply 2 resistors in series with a voltage input and a grounding source. Okay. So in order to get the voltage, what we want to do is we plug it into the 5 volts on our breadboard, and then we pick whichever row we want to work with. Okay. Then we know that the voltage from this 5 volts needs to go into one side of our 1 kilo ohm resistor. So we just plug one of these legs of the resistor into any of the holes that are in the same row and column as our 5 volt source. And then for current to flow, we need the other leg to go into its own potential area. So that just means not connected in the same 6 holes as the first leg of our resistor. Okay? And then we know the output of that first resistor needs to go to the input of our second one. Once again, we need to pick one of the holes that are in the same row as our first resistor, and then plug it in a separate row there. And then finally, to complete the circuit, we just need to use a wire to send the output of our second resistor to ground. Okay, and now we have our full circuit. Our 5-volt DC input goes into our first resistor, then the output goes into our second resistor, and then the output of the second resistor goes to ground. And that's our complete circuit. So now that I have set up the circuit, I want to show you how to use the multimeter to take voltage readings. Okay? So obviously, first thing we do is we want to turn on our breadboard, and now we know we've got a 5-volt supply running through our circuit. Okay. Then for the multimeter, you'll see in order to measure voltages, specifically of the DC variety, we use this top left-hand corner of our multimeter here. Okay? And just like with the resistors, you'll see these values here they give you is what the maximum voltage you can measure at each of those points. So for example, if I set it to 20, that means I can measure anything up to 20 volts. Okay. Now to demonstrate how to use it, with our black lead, you always place that on a grounding point. So you'll see on this breadboard, there's 4 different grounding points, and it doesn't make a difference which one you choose. So for example, I could use this one in the bottom right-hand corner. Okay. Then for the red lead, you now place that wherever you want to take your measurement. So for example, we want to measure the input voltage of our circuit. So I'll place it in any of the holes along this red wire here to measure the voltage. And now you'll see our input voltage is 4.95 volts. Okay. Then the other kind of voltage we want to measure is the output voltage, which that occurs between the 2 resistors. So we leave the black lead attached to ground, and we move the red lead to any of the points between the 2 resistors. So we can touch it to the output of the first resistor. We get our 3.4 volts there. Or you could touch it to the input of our second resistor, and we get the same value there, 3.4. Okay, so that's how you use your multimeter to measure voltage. So now I'm going to show you how we use the oscilloscope to take measurements for our circuit. Okay, so you'll see for the oscilloscope, this time we have just a single probe. There's no probe that you'll use to attach as a grounding point. So you could think of this as basically just the red probe from the multimeter. All we need to do with this one is plug it into the point where we want to measure. So for example, if we're measuring our input voltage again, we just touch it to the starting side of our first resistor, or the same line as our 5-foot input red wire. And we see on the screen you get a line there, which is obviously not the full information. So now when we want to get an actual value of our screen, what we need to do is set it on our oscilloscope. So you'll see here in the right-hand corner, we've got a measure button. We push it. We want to check which source is channel 1, which we're measuring from. And then we want to measure a voltage. And then it's already set to max, so all you do is push enter. And you'll see now we get a voltage reading in the bottom left-hand corner of the screen. And then we just remove the menu. Okay. So now we've got our voltage reading for the input. And then to get the output, all you're going to do is once again move it to the line where the 2 resistors meet. And we'll see there we get our output voltage. So now what we want to do is make a slight alteration to this circuit and study the effect it has on the output. So how we're going to do that is we'll leave our second resistor fixed at the 2.2 kilo ohms, but we're going to be changing our first resistor to different values. Okay, So just as before with the new resistor, we need to measure the exact value of the resistor using the multimeter. So we just, once again, pick 2 random points on the board to place our resistor. Okay. Then we're going to change our multimeter setting. So this resistor is a 10 kilo ohms. So I know if I set it to 20K setting, I should be able to measure it. Okay. And then same with the resistor, you just put the black probe on one side, the red probe on the other side. Okay, and then we see for this one, our resistance is 10.04 kilo ohms, which you take note of. Okay, so once we know that exact value, now when you're changing up a circuit, you must make sure to first turn off your breadboard before you make any change. Okay, and then all I'm going to do is swap out this 1 kilo ohm resistor and plug in the 10 kilo ohms where it used to be. Okay, then we turn on our board again. So we've got our 5 volts flowing in, and then we're just going to repeat our voltage measurements again. So we've got our multimeter set to the 20 volt division again. Black probe always goes to ground. And then the red probe goes where we want to measure, which will be our output. And then you'll see now that the voltage we get at the output has decreased significantly because of the change of our R1 from 1 kilo ohm to 10 kilo ohms. Okay? Once you've got that, we want to take our oscilloscope reading again. Once again, you're just going to plug the point of your probe to where you want to measure, which is between the 2 resistors. You plug in, and then we'll see our new voltage reading, which you'll record, and that completes it. All you need to do then is change your R1 to different resistors and record how your voltage output changes on both your multimeter and your oscilloscope, and that completes the first part of part 1. So now for the next part of the experiment, we want to work with an alternating current voltage source. So to get that, we're going to move our red wire, instead of for the DC point along the side, we're going to plug it into this central point here at the top of our breadboard, which provides us with our AC voltage. Okay. Right. So now we want to take our input and output voltage measurements again using both our multimeter and our oscilloscope. Okay. So if we start off with our multimeter. Okay. So now we're dealing with an alternating current, so we need to use a separate setting on our multimeter. Now we're going to go to this top right-hand side here, to the 200 setting here of our voltage reading. Okay, and then as with our previous voltage readings, you always just want to place your black probe on a ground, and then the red probe goes for wherever you want to measure. So for example, we want to measure our input voltage. We touch it to that first set of holes again, and we see here we've got 3.1 volts is our input voltage. Okay, and then for our output, we just move the red probe to where the 2 resistors meet again, and we see our output voltage is now 2.0 volts. Okay, then we move on to our oscilloscope reading. So we'll see for this one, we don't need to change any of the initial settings we had for the DC. We can just plug it in to get our input. Okay, and then we'll see here we get a waveform here. It's very tightly spaced. So what that tells us is that the period divisions of our oscilloscope aren't at their ideal setting. So all we need to do is change that until we get a clearer picture. Okay, so now we can see is our waveform of our alternating current, how it goes from 0 down to its minimum value up to max and so on. And we get our voltage reading there of 5.52 volts. And then to get our output, once again, you just move your probe to the desired position, which is between the two resistors. Plug it in. We'll see there we get our waveform again and our new output voltage. Now, just help here, sometimes there's a little bit of instability. So what you can do is you'll see on this top right hand here, you've got a run stop button. You can just push stop, freeze it, and record the values you need. But just make sure that once you've taken your values, you push run again. Because otherwise, any change you make to your circuit won't be picked up. It'll just be frozen of your initial circuit. So now that we've got our alternating circuit set up, what we want to do is change the value of our R2 resistor to different values and see the effect it has on our output voltage. So we'll leave our R1 fixed this time around, and we're going to be changing our R2. Okay? So we take out the old resistor. Now, for this one, as with usual when it comes to resistors, if you haven't been keeping track of what the exact values are, you will need to measure again with the multimeter. But since I know this is the same 10 kilo ohm I used previously, I can just plug it into the circuit and move from there. Okay, so we complete our circuit again. Okay, and then we're just going to take our new output voltage readings using both our multimeter and our oscilloscope. Okay, so for the multimeter, once again, we want that top right-hand setting of 200. We're going to place our black probe at a ground and our red probe between the two resistors to get our output voltage. Okay, we get 2.8. And then it's just back to using our oscilloscope to get our output voltage. Plug the probe in again. Take our new reading. And that's all you're going to do for the rest of this part is alternate, change your R2 value to different resistors and record what your output voltage is with both your multimeter and your oscilloscope. All right, so now we're going to move on to part 2 of the experiment, which is known as the loaded potential divider. So we're going to start off by setting up the same basic circuit as part 1, but now we'll be using two 4.7 kilo ohm resistors instead of what we used previously. So as with the first part, we need to verify what our exact resistances are. So I'm going to use the multimeter to measure the exact resistance of our two 4.7 resistors. Okay. So same as before, we set it onto our desired range of our resistance. 20 kilo ohm should be sufficient for this. Touch the one black probe to the one side, the red probe to the other side, and we see it's 4.69 kilo ohms, or 4.68. So you record that value. And then for our other resistor, black probe to the one side, red probe to the other. And we see this one is 4.69. We record that value. Okay, so we're going to build our circuit again. We're dealing just with DC 5 volts again. So we can take our wire from the 5 volts of our breadboard, attach it to one row of circuit holes. Then we've got our first resistor. The one side goes to the same as the 5 volts. Other side comes to its own potential. Then we plug in our second resistor. So the one side goes to the same potential as our first resistor, and then the other side goes to its own potential point. And then finally, we need to ground the end of our circuit. Okay, so now this is our initial part 1 circuit set up. Now the alteration we're going to make is by adding a load to our second resistor. So all that means is we're going to add a second resistor parallel to our resistor 2. Okay, so I'll take the 1 kilo ohm from the first part, and now to make a circuit in parallel, we need the input of our resistors to be the same. So we're going to attach the one side of the resistor to where the first and second resistors meet, and then the other side of this third resistor is just going to be to the same output of our second resistor here, where it's grounded. And now this is our new circuit setup. So now, once we've got this loaded circuit set up, all we want to do is take our necessary readings. So for part 2, we're no longer going to be using the multimeter for voltage readings. We'll just be taking our oscilloscope readings. Okay. So once again, to get the input of this circuit, we're just going to take our probe and place it for where the input of our circuit is. So in this case, the purple wire. And we record our voltage reading for this circuit here. And then to move the output, we want to take it to the point where all 3 resistors now meet. Okay, we take our voltage reading. Then the change we're going to make for this circuit is we're just going to be swapping out our third resistor, also known as the load resistor, to different values and seeing what effect that has on our output. Okay, so I'm going to swap out the 1 kilo ohm for one of the 10 kilo ohms we used from part 1. If you're not certain of the value, you would have to measure it again with the multimeter. But since I know what this value is from the first part, I'm just going to plug it directly in to our circuit. Okay. Then all we do is take our output measurement again. And we'll see we've got our new value. And then to conclude this part, all you're going to do is change this load resistor to 5 different resistors of varying values and recording the effect it has on the output of your circuit. Okay, so now what we want to see for this section is the effect of our frequency of our input has on the output of our circuit. So how we're going to do that is, you can see with our AC source from the board, it allows you to change the frequency to different values by adjusting these 2 dials here. Okay, so you'll see right now we're on 3 kilohertz, and we want to change it to a different setting, say 10 kilohertz up, we go to 40. Then all you're going to do is take your voltage measurements again. We're still dealing with alternating current, so we can set it to the 200 on the alternating side. The black probe goes to ground, and then the red probe goes to where we want to measure. And we get .1 volts. Okay? And then we want to use our oscilloscope to measure the voltage again. We just take our probe, place it to where the 2 resistors meet, and we record our new. Okay. We record our new voltage reading. So just once again, you can see a little bit of unstableness, so you can just stop it, record the value you want, and then just remember to run it again afterwards before you make any further changes. Okay, and then to conclude this section, all we're going to do is increase our frequency in 10 kilohertz divisions and measure our output voltage using both the multimeter and the oscilloscope for 5 different frequencies. And that'll finish off the section. So now we're moving on to the final part of the experiment. Okay, so what we want to do is see what effect we can have on this system by altering the input voltage and measuring the response in both the output voltage and the current of the circuit. Okay, so we're going to start off by setting up a similar circuit to part 1, but now what we want to use is two 100 kilo ohm resistors instead of the 1s and 2.2s from the first part. So as with usual, when we're introducing new resistors, we want to take their exact readings using the multimeter. So you just plug your resistors to different sets of points again. Okay, we'll take our multimeter. Now we know we're looking for resistors that are about 100 kilo ohms. So what we want to do, instead of stopping at the 20, we're going to go to the 200 kilo ohm range. Okay, and then as before, black probe on one side of the resistor, red probe on the other. Okay, we see that's 99.3 kilo ohms. We record that. And then for our other resistor, black probe on one side, red probe on the other. And we see this one is 100 kilo ohms. Okay, so we set up our simple circuit again. Now what's going to change here is we want to have our input voltage being a variable DC voltage. So you'll see here that we've got on this port here, we can vary our voltage between 0 and positive 15 volts just by turning this dial here. Okay, so we got that for our circuit. We're going to plug our 100 kilo ohm resistor to the output of that purple wire, and then the output of this resistor goes to its own point. And then we need the output of our first resistor going to the input of our second resistor, and then our second resistor output goes to its own potential again. And then finally we complete our circuit by going to ground. Okay. So now we're going to introduce a new measuring device on our breadboard here. You'll see in this top right-hand corner, we've got our ammeter. So this will measure the current for us. Now, in order to use that, we need to attach two additional wires to our system. Okay, so the first thing we need is, you'll see at the top here, we've got our ammeter points here. The negative side needs to go to ground. Okay, and then the positive side, okay, we'll just have one wire connecting into the positive port of the ammeter, and then we're going to leave the other side of the wire freely hanging for the moment. Okay, so now, once again, we're just going to use our oscilloscope for our voltage readings. We're not going to use the multimeter for this part here. Okay, so the first thing we'll do is we plug into our input of our circuit here, and we're going to want to adjust our voltage reading of our input to approximately 2 volts. Okay, so now we've got our input voltage set to 2 volts. Then what we want to do is measure our output voltage. So you plug it in where the two resistors meet again. We'll record our output voltage. Okay. Then you remove the probe, and now we want to measure the current in our circuit. So you're going to take the freely hanging pink wire from before and plug it in between where the two resistors meet. So, and now you'll see there that the needle on our ammeter has moved to a reading here. So in this case, it would be 18 microamps, and you take that recording. And then you're just going to make sure, once you've taken your reading, always to unplug the ammeter. You don't want to leave it plugged in any longer than you need for your measurements. So now that we've got our basic circuit set up, we want to see what changes are made to the output voltage and current by changing the input voltage. So how we'll do that is I'm going to plug the oscilloscope probe into the same voltage line as our purple input wire or the input of our first resistor. Okay, then all we're going to do is increase our voltage by 1 volt. So we were at 2, so we want to adjust it to, okay, well, as close as you can get to 3. So what's always important for this experiment is the values you get in your template are the target values. So you always try to get as close as you can, but you record your actual value, not just what the target value was. Okay, so we've got it set to 3. Then all we're going to do is measure our output voltage again, where the 2 resistors meet. You'll take note of that, take that out, and plug your ammeter back in where the 2 resistors meet. We'll take our new reading, which is roughly 28 microamps. And then once again, go back to your input, increase it to your next reading, 4 volts, measure our output, measure our current, and you're just going to go up in 1 volt divisions until about 10 volts, and that completes part 3 of the experiment.